Okay, now we have the solutions for question 12. 12a, 1 minus 3 cosine on 2x. Okay, first and foremost, if you know we equate 2x equals to pi, we get to know that the period x equals to pi. So the period is actually pi. So what you should get is one full cycle of the cosine graph, okay, in pi radians. Okay, so we should only have one cycle. Next thing here we know is this. We see that the amplitude, right, is actually -3. So the negative sign, right, you notice that here we have -3 to 3. What I've drawn here in the, what I've drawn here in the dotted line is actually -3, this point here, okay, this dotted line is -3 cosine of 2x. Why is it flipped over? We know that the cosine graph actually comes down this way and goes up. The negative sign will flip the entire graph along the x-axis, or reflects it rather. You get -3 to 3, go down. Alright? And why is it 3 to -3 and not 1 to -1? It's because the amplitude is 3, that's why it becomes 3 and -3. Finally, we know that there is a +1 down here. So +1 means that every point will shift up by 1. So -3 becomes -2. Okay, this portion here, 0 becomes 1, 3 becomes 4, 0 becomes 1, and -3 becomes -2. And you are done with 12 part A. Okay, for 12 part B, is given that cosine theta is -3/5 and that theta is greater than 180 degrees but lesser than 360 degrees. So first thing we know that is cosine is obtuse. Okay, so obtuse, right? A, S, T, and C. So obtuse means it's in a third and fourth quadrant. So no matter what, sine must be negative, because if cosine theta, okay, theta lies in third or fourth quadrant, it doesn't matter. Sine theta itself, because in third and fourth quadrant, will be a negative ratio. Simple application of Pythagoras' theorem will yield that we get sine theta, okay, is equals to -4/5. And down here what we get is, without solving for theta, so sine theta, as we have established earlier, sine theta is equal to -4/5. You simply put in the correct values here and you just use your calculator and you should get that the value is 1/7. Okay, for 12c, okay, we have to show that secant square x minus secant 4x is equals to negative tangent 4x minus tangent square x. Okay, what we do here is this. First, if you notice from the left hand side, I notice that common term is secant square x. Okay, what I have done is I factorized secant square x here, leaving this inside the bracket. Here, what I have done is I've applied the trigonometric identity. Okay, how do we get this? If you look into your formula sheet, you know that 1 plus tangent square x is equals to secant square x. So by logic, okay, or simple, okay, there's no logic to see here. I just replace secant square x with tangent square x plus 1. You multiply in, okay, you expand the brackets, you get negative tangent 4x minus tangent square x, and it is shown. Very simply put, right, why we have to substitute this is because, you know, the left hand side, everything is in terms of secant, while what they are attempting to do is to get you to prove that is equals to a function in tangent. So what we aim to do is to use appropriate formulae to change everything that is in terms of secant into something that's in terms of tangent, and you should be able to prove part C. Okay, for 12 part D, first, we notice cosine here, sine here. Looks difficult to solve, okay? So, but no worries. You apply the formula, okay, that cosine square x is 1 minus sine square x. If you're wondering how I got that, well, simply sine square x plus cosine square x equals to 1. So, therefore, cosine square x equals to 1 minus sine square x. So basically what I'm trying to do is I'm trying to obtain an equation where everything is in terms of sine x. So by replacing cosine square x with 1 minus sine square x, you notice that here it is sine square x, here is sine x. You rearrange, you get a quadratic trigonometric function, which is 6 sine square x minus 7 sine x plus 2 equal to 0. I apply factorization. What I get is 3 sine x minus 2, 2 sine x minus 1 equals 0. Sine x is 2/3 or sine x is half. Down here you find the basic angle. Okay, you get 41.8, you get 41.8 and 138.2. Because sine is positive, it should lie in the first quadrant or the second quadrant. Sine x is equals to half. Okay, this is a special angle, so straight away you should know that when sine x is half, x is either equals to 30 or 150 degrees. And that concludes the solutions for question 12, part D.